In this video, we are going to be looking at the distributive property. We will start with the definition, which says that it's multiplication that distributes over addition or subtraction. Let's look at 3 examples that are purely algebraic. Our first example is 2 times 3x minus 8. And before we get started, I want us to remember that multiplication is repeated addition. So 2 times anything means I'm adding that something together twice. Right? Because multiplication is repeated addition, for this first example, I'm going to show that we're taking 3x minus 8 and we're adding it together 2 separate times. We'll shorten this process down over the next 2 examples. I can go ahead and get rid of my 2 sets of parentheses and just make this 3x minus 8 plus 3x minus 8 again. And now I can start finding my like terms so that I can combine like terms. I say I have an x here and here. If I take positive 3x and add another 3x, that is going to give me a total of 6x. I also see that I have my 2 constants, negative 8 and negative 8. If I take negative 8 and combine it with another negative 8, that gives me a total of negative 16. Okay, so that's one way of solving this, but if we use the distribution property, what we can do instead, taking our original problem, is just take that 2 and distribute it over the subtraction sign. So I'm going to take 2 times 3x, and then I'm going to add 2 times my negative 8. I'm going to put my negative sign in parentheses. 2 times 3x gives me 6x, and 2 times negative 8 gives me negative 16. So either way, I end up with the correct answer, but by using distribution, I can get there quicker. Let's look at a second example. In the second example, we're going to take 6 times 4x plus 2 minus 3y. So we're going to have 3 terms that we distribute across. Now, I don't want to write out 6. I don't want to write 4x plus 2 minus 3y 6 times. So instead, I'm just going to distribute across. I'm going to take 6 times 4x. I'm going to take 6 times 2. And I'm going to take 6 times negative 3y. When I take 6 times 4, I end up with 24x. When I take 6 times 2, I end up with 12. And when I take 6 times negative 3, I end up with negative 18y. Now, I want to draw our attention to this plus negative 18y. We don't want to have dual symbols like this. And anytime we see plus minus, we're just going to simplify that to be one subtraction sign. So this will become minus 18y. All right, and like before, we want to put our expression in alpha order. So we're going to take 24x minus 18y plus 12. And that is my final answer for this problem. Okay, let's look at one last example. And in this example, we're going to combine our distributive property with combining like terms. So we're going to start with 2 times 4x minus 5. And then outside of my parentheses, I'm going to put that I have plus 6x. All right, so I'm only going to distribute to what's inside the parentheses. So 2 times 4x gives me 8x, and 2 times negative 5 gives me negative 10. And then I'm just going to pull my plus 6x down and tack it to the end. But I have not doubled it because it was outside of that original parentheses. Now I'm going to find my like terms. I have my 8x and my 6x. 8x plus 6x gives me 14x. And then I have my minus 10. And that is my final answer. Let's go ahead and apply this to a geometric concept. So in this example, we have the measure of ST. The total measure is 6y plus 2. Then we have SA, which is equal to 3y plus 1, and we want to solve for this missing AT. So to do that, we're going to set up our equation using segment addition. I know that I can take the big part, ST, and subtract the small part, SA, that I know, and whatever's left over is going to give me my second small part, AT. So I'm going to go ahead and plug this in. I have 6y plus 2, which was given to me in the example, and I'm going to subtract 3y plus 1, but I want to make sure that I put it in parentheses, and I'm leaving a little bit of space here for a reason, right? And I know that once I subtract that, that gives me my missing AT. Now, if I'm subtracting a total, I'm actually subtracting an invisible -1 times what's inside the parentheses. And this actually requires me to use the distribution property, the distributive property. I need to take this -1 and distribute it to 3y and +1. And when I do that, my new equation is going to be 6y plus 2 minus 3y minus 1, because -1 times 3 is -3. And -1 times +1 is -1. And I'm having just a few issues here with my Apple Pencil, so give me just a moment. But that is going to equal AT. Now I can combine my like terms. So I have 6y and 3y. -3y, so 6 minus 3 is 3y. And then I have +2 minus 1. So my answer is that AT is equal to 3y minus. That should be +1. So my final answer is 3y plus 1 equals AT, and that concludes our video over the distributive property.